how the parabola changes if you change the A, B, or C values. Okay, so the effects of A, B, and C on the parabola. So if you have it in general form, like this, A will tell us two things: opening, up or down, no changes there, right? We know that already. It will also give us the width. If you change B, how is that going to change? How is that going to affect my graph? Okay, so before I tell you, I want to show you. I'm using my iPad, that way it's on the video. So let's, for a minute, just look at this curve here. I know you might have used Desmos before. I don't know if your teachers did, but Desmos is free, desmos.com. You can enter any equation you want. But I just enter A, B, C, right, just like that in standard form. So we all know already. Let me just zoom out a bit. If we were to change the sign of A, it's either pointing down or pointing up, right? Also, if you increase, it gets narrower, right? If you increase, it gets narrower, narrower. The more you increase that. And if you go between 0 and 1, it's a wide curve. Okay? And then changing the sign will make it point down. However, let's make it point up for this exercise. Look at what B does to your graph. If I change it, if I slide, I have a slider here, right? It does a bit of a side shift. I don't know if you see it, right? You go from one side to the other side. And you might say, well, it also changes my up and down a little bit, Mr. Dirks, and I see that there, right? Sure, I would agree with you, but B isn't that important to us. But you can know that it does make a change. Remember I said when B is equal to 0, then your vertex is also your y-intercept. It's not 0 there. It's hard to get it. Come on. There. If B is equal to 0, then your y-intercept is also your vertex. But as soon as B changes, the vertex shifts away from the y-intercept. So that's another thing that you can kind of think of, okay? So that's what B does. It does a side shift. But now look at C. C is the one I really want you to know what it does. It shifts everything either up or down. And notice that C is my y-intercept, so I actually labeled it. So as you move, so you might think, oh, C just changes the y-intercept. Yes, but it also changes every single point on that graph. It either shifts it up or it will shift it down, okay? So that's what I want you to know what A and C will do to the parabola first and foremost, okay? Those are the most important ones. So let's add that to our notes. B will do a side shift. So I'll just say it up here, side shift. Okay. So if this is your graph, right, it will kind of move it like this, right? It will go from side to side. And this is where it gets a little interesting, guys. If B is negative, it will shift it to the right. If B is positive, it will shift it to the left. Not too critical, this one. Okay, I'm not too, this one is not, but I think it's still cool to know. And then C will do a vertical shift. H35, vertical shift. So if you want to just do a little grid here or a coordinate, right, you could go up here. How about we just this vertical shift like this. And in this case, it's actually not counterintuitive. If you increase it, your graph will shift upwards. If C is decreased or negative, it will shift down. Okay. So I think these are important concepts, especially because sometimes I ask you, hey, come up with another equation that would result in a parabola that has a lower maximum height. You would want to, maybe I should add that, right? Because sometimes, like, you'll forget, and after spring break, you might forget. Okay, so I will just add here decreasing C will shift the entire curve downwards. I don't know if you can see that. Decreasing will shift the entire curve downwards, and vice versa. I think if I could say, hey, what's new about this? I would want you to focus on C, right? Like, that's the new. A, we've talked a lot about. B, I don't really care too much about, but C is the one you want to know, because changing the C value is going to help you down the road. Okay. All right. Maybe one more here. Just an example. Example, if you had h of t is equal to negative 4.9 t squared plus 25t plus 7. This is not 100% accurate, but you would start at 7 and go like this. Okay. H of t, I'm going to copy the exact same equation, but now I'm going to go plus 10, let's say. Plus 10. So everything else is the same, but C is increased. We will now have, I'll use red for this line. You would start at 0, 10, and the entire curve would be higher up. Okay, so every single point, even the vertex, has been increased to it being higher now. Okay. H of t, negative 4.9 t squared plus 25 plus, let's say, 3. I'm going to use a blue pen or whatever you have, highlighter, you name it. Mine doesn't seem to work. Let's see. There it goes. Right, it decreased over to here. And so you have 0, 3 at the bottom. So I used blue here, red, and pencil. And I will just highlight the, and that's that one, that I changed C. I increased it or reduced it, right? In fact, had you known your vertex, let's say it's you know, 412 originally, and you increase your C value by 3 units, your vertex will also, the Y value will be increased by 3 units. So there it is. Okay, we'll pause here. I'm going to ask you to go to, I want you to try page 40 and 41 on whiteboards, but we're going to start with 40. I'll say the rest is still very important for you to do. Rizzy and Ariana live in houses that are next to each other. Nowadays, the houses are really close together. Rizzy lives in a 2-story house, while Ariana lives in a 1-story house. They throw a tennis ball at each other through their open windows. The path of one particular throw from Rizia to Ariana is modeled by this equation here. Very important, right? Where f of x is the height of the ball above the ground and x is the time in seconds. So remember, whatever is on this side is your x variable. I have x variables there anyways, but that means that we have time. Make sure you write this down. Time and height in that order. X is time, Y is height. 90% of the battle is basically, I give you an X value, find the Y. I give you a Y value, find the X, right? That's basically how this goes, okay? And a lot of you missed this, so make sure you read, because not all of them hit the ground. Ariana catches the ball 5 feet above ground. So I'm going to quickly enter this into my calculator. You should do the same if you haven't done so already. I know I'm running against time here, so I'm going to be a little faster, but remember the video of this is actually posted. My window is not really good. Okay, so that's one thing you need to play with. If I see that there's a lot of space on the Y max here between the Y max and my graph, I reduce my Y max. So whatever it is, if it's 70, I'm going to go half of that. Try it again, okay? There's still a lot of space here between the X max and my graph. So I'm going to reduce my X max to 5 is probably going to be, oh, it's still good. Right, so this is what I've done. I tried to look at my graph and see everything. Don't go too much into the Y min and the X min. Don't go too far, because then most of your graph is taken up by those quadrants that you don't want to see. Okay, so you have that there. How long does it take for Ariana to catch the ball? Let's do that here. A caught at a height of 5 feet, right? So let's make a note of that, okay? Not the ground. Does not hit the ground. So you're going to have to be a little Speedy Gonzalez here with writing this stuff, okay? So y2 is not equal to 0, but equal to 5. Second, trace, intersect, okay? So we go y2 is equal to 5. Hit graph. You don't have to do this right now because you did it already, right? So just maybe watch here. Do not find the negative here. This is going to be negative time. You can't include that. Your graph starts here and then stops there, okay? That's why the calculator doesn't know this is a word problem. Second trace 5. I'm going to go closer to that one. Enter, enter, enter. 2.255. That is the point you just determined, but it says it takes 2.25 seconds for Ariana to catch the ball. Okay, it doesn't hit the ground. B, what's the initial height? Right, it is the y-intercept, which is 0c. This means it's 0.18. In this case, the y-intercept is 0.18, which makes sense because it's being thrown from a two-story building. So 18 feet, right? You got to state which one of these two is it. So 18 feet above ground. C, what's the maximum height? Guess what that is? Second trace, max, right? We're going to find the vertex here. So sometimes you find all the points you need to graph. Sometimes you need to find those points later on. I'm not always going to ask you to find everything, okay? So sometimes you're going to have to take the initiative and do that. So second trace, max, you got to go to the left of it. You're pretty good at that. I'm not too worried. That is a bonus here. So it's 0.71, 21.57. Please show me the point and then say max height is 21.57 feet. Okay. Perfect. D, shifting over. How high is the ball after 2 seconds? Folks, what are they giving you here? Time is 2. What is the height? That's what they're telling you. So we're going to use second, trace, value, x is equal to 2. Okay. Second trace 1, x is equal to 2. And there it is. Our height is 10 feet at that point. And I'm usually elaborate a bit more on my answer, but today I'm just going to leave it at that. E, state the domain and range of the scenario. You know what? I like to have a little sketch. Oftentimes I graph this thing first before I do the domain and range. But in this case, the domain starts at time 0. It's caught 5 feet above ground, correct? So it's this is where the action stops, 2.25 seconds after it's thrown. My range goes as low as 5, it never hits the ground, and as high as 21.57 feet. Okay, so domain and range should be visible when you graph it. When you graph this thing, your domain and range should jive. Okay. Here we go. I'm going to graph this. Oh, let's do the equation. An equation that would have a greater maximum height. Here it is. It's not rocket science. All you need to do is increase the C value. So 19 would do. 18.01 would do. Anything bigger than 18 would do. Okay? Don't go right after the bell. I'm going to give you a take-home AC, okay, on this. So here it is. Time in seconds, height in feet, okay? I'm going to use a scale of 0.5 down here, 0.5, 1, 1.5, 2, 2.5. It works just fine. And my height, I'm going to use 5 at a time here. 5, 10, 15, 20. That'll do. I'll just go one more, 25. So your graphs, I have to say, look pretty good. So my initial is, this is going to be, we'll just leave it there, okay? I don't like to hold you back. I don't want you to be late. However, this is posted. I have a PDF and I have a video of this. So how about this? Your homework is page 38 to 41. And you're like, I already did 40. Do it again on your own, okay? So I'll just give you an AC on Monday instead of you taking it home. How's that? Okay? So it's going to be based on word problems. So make sure you know how to do them.